Published the 25th of May 2018 by Clive Ashmore. Why print offsets occur and how to correct them. Printing offsets, the degree to which a material deposit is off-center from the pad, can occur due to three primary elements of printing: the printed circuit board, substrate, the stencil and the printer. Each has to be manufactured and is surrounded by a process bandwidth, each with its own tolerances that can accumulate. Add to this the variables from different manufacturing methods, sites and base materials and, well, offset inevitability becomes obvious. Let's begin with the board and stencil. Gerber data is king, it's where the designs begin and is the blueprint for PCB and stencil manufacture. Simply put, Gerber is an x-y coordinate and angle for a certain feature size and shape. When an offset occurs, it is the difference between what the Gerber says and what is actually produced. At the PCB level, the offsets derive from the artwork, the subtractive chemical process, and the FR4 laminate. Each of these has the potential for variability, as in the case of FR4 that can stretch and move during temperature processing, because the coefficient of thermal expansion, CTE, is relatively poor, especially considering today's dimensions. Given these realities, the board could be off in one corner, or it could be a gradual movement from the left corner to the right, from the center outward, or just focused in one area of the board. Likewise, the stencil experiences some of the same issues, as it is also a manufactured product subject to varying conditions. The laser requires proper and regular calibration. Otherwise an aperture cup may be oversized or undersized. Substandard stainless steel could be used in manufacture. CTE is a factor with stencils as well. This is a very, very thin piece of metal, and only getting thinner. When it's manufactured at 26 degrees Celsius and then a customer uses it at 22 degrees Celsius, the material stability can change. In addition, a traditional mesh-mounted stencil's tension can change over time with use. The stencil can begin to sag, which is terrible for high-accuracy printing. Finally, there is the print platform itself. A good machine is built with offsets. The art is to calibrate the offsets out so the machine is as precise as the actuators and the alignment system, which today can be as accurate as 10 micrometers to 12 micrometers. If the machine is not maintained, however, it can also contribute to misalignment. Regular maintenance and calibration is critical. The reality is that none of these factors is going to change in the next 5 years, so offsets are here to stay, at least for the foreseeable future. The question is, how do we correct for them? In days past, an experienced engineer would do a couple of prints, look at the board under a microscope, make the necessary adjustments, and repeat this process until it was good, or at least good enough. The rub is that while the engineer may have gotten the offset correction spot on in the morning, a different batch of boards is loaded in the afternoon, and the morning's offset adjustments may not work for the new set of substrates. But this is not discovered until defects, such as insufficiency and bridging, have already occurred. That's the beauty of today's latest technologies. I'm not talking only about solder paste inspection (SPI) systems, which, to be fair, are great at collecting and storing mass amounts of data. The challenges analysis and corrective action are still manual tasks and usually take place after the event. The most useful systems are those that identify, in real time, the process is starting to drift and make corrective actions to keep pace on the pad and production humming along. The degree of intelligence and historical data reference built into these tools is immense. Instead of relying on preset thresholds, as is the case with traditional inspection and measurement equipment, more effective systems essentially self-learn. They analyze, stabilize, optimize and correct. As mentioned, offsets on the board can occur in a variety of different locations, so taking average measurements from the four corners and the center of the PCB without any regard for the board's aperture sizes, shapes and distance is basically correcting offsets that are already out of spec. That's a conventional approach. New technology selects critical apertures in the most challenging areas of the board to drive a more comprehensive, preemptive offset correction methodology. Of course, plenty of engineers still prefer the microscope, especially if they have to analyze all the SPI data anyway. But for those working in the world of miniaturization, high volume and competitive margins, intelligent and throughput-enhancing offset correction can be the difference between good yields and bad, or profit and loss. The great news is the path to automated offset adjustment is smarter than ever. Alexa, correct my offsets. Someday, maybe. Clive Ashmore is Global Applied Process Engineering Manager at ASM Assembly Systems, Printing Solutions Division, ASMPT.com. Clive.Ashmore at ASMPT.com. His column appears bi-monthly.